How's it going, everyone? So today I'll be explaining the algorithm on how I utilize the millis function when it comes to dealing with the power consumption concern that I've had when I did not utilize the servo motor. So to start this presentation, first I have created the constant variable, which is event start, and that is equals to 1000 milliseconds or 1 second. Um, the reason why that is 1 second is because for every 1 second, the robot's gonna try to adjust itself by moving backward instead of just changing its direction with the left motor or the right motor. Let's just say the first motor uh, moving to moving forward. The right motor is moving backward, or the second motor. And then if that takes a little too long, like 1 second, the robot's gonna decide to move backward a bit. Okay, so now the reason why we've used also unsigned long is millis function is going to be generating a really big number, or a large number, gargantuan, yes. And I just want to make sure that these variables would have enough storage to handle that kind of number, those kinds of numbers. So now for the second line of code here in this area, we have unsigned long update time, which is equals to 0 because this variable is going to be updating the time, and you will see how that actually works as we go along with the presentation. So now let us go to the void setup. In the void setup, I have initiated the serial communications with the serial.begin function at 9600 SIP bar rate. And let's go ahead and go to the void loop. Over here, I've created the variable named present time. This variable is going to be the one that will be holding the values generated by the millis output. And this millis function, again, as I've specified earlier, it's going to be generating large numbers, and this is why I've used unsigned long in order for the variable present time to hold those giant numbers. In order for it to have enough storage, yes. And over here, I have created if statements where if an object is too close, or if the ultrasonic sensor detects an object that is too close to the robot, it's going to decide to move in another direction. It's going to turn, yes, and look for other clear paths so it can go towards that. The left motor goes backward while the right motor goes forward, and then eventually, if let's say that takes it takes 1 second, which is in this code, that's already a lot of time, which it makes the condition true. It will activate this if statement. And then I'm going to try to explain this as briefly as I can. And I want you to imagine the present time going up, up, and up. It's just a variable that just keeps going up because, again, this is the one that holds the outputs from the millis function after all. So let's say we start at 10 milliseconds minus 0, which is the update time. The update time starts at 0. Is that greater than or equal to event start, which is our constant variable, which is a second? Is that greater than that? No, obviously not. So we're not going to be executing these lines of code, and we're going to be skipping them over, and we're going to reach at the end of the loop. We're going to go back at the start and then go back here again. Now let's say we've come across the 1 second mark. Now this time, is 1000 minus 0 greater than or equal to event start? Of course, we're going to say yes. And then this time, as I've specified earlier, it's going to be doing a backwards motion. Left motor goes back, right motor goes back, and it's going to be doing that by a delay function, which is 500 here. Because if I don't add this delay function, it's not even going to move backwards at all. It's just going to be jerking a bit, which is kind of weird. It's going to be jolting in a weird fashion. So I decided to use the delay function here with this value so it can actually do the job. And after that, here comes the fun part. The present time, which was 1000 milliseconds or 1 second, is going to be this value is going to be placed to update time. Update time is going to be not 0 now. It's gonna turn into 1000. So let's say we run the code again. I mean, let's say we go back to the top of the void loop, and then the present time becomes 1015 minus 1000. So 1015 minus 1000 will become 15. Obviously, 15 is it greater than or equal to 1000? That's incorrect. Now, it's gonna keep skipping these lines of code until it gets to the point where it goes on a 1 second on a second interval again. And eventually by that point, update time is going to become 2000, and it just keeps getting up higher and higher. So basically that is how I utilize this advantage with the power consumption concerns that I've had. Thank you guys for watching this video, and I hope you had fun trying to understand this as much as I did. And yeah, I hope I can see you guys in the next one. Good day to you.